Hello everyone, this is Pragya Nayak and this is Mahek. We are student of VIT and today we are going to discuss about system calls in Unix or Linux. So a system call is a request in a Unix-like operating system made via software interrupt by an active process for a service performed by the kernel. Basically, system calls are used for communication between program and hardware. So the first system call we are discussing about is makedir. So here it is the syntax for makedir. Int makedir constant character pointer pathname mode underscore t mode. So makedir is used for make a directory. Makedir system call. This method is returning a integer with the parameters constant char pointer pathname mode underscore t slash mode. So in pathname we are giving the path where we want to make the directory, and in mode we are giving the mode as the access for the directory. So in this program we can see how we are using this system call in C program. For this we are using unistd.h. So as you can see, we have make a variable of integer type I. In this I, we are assigning a function call. The function call will return the integer. We are giving the name operating system. So a directory will be created with the name operating system with the mode 0777. So if I double is equals to 0, it means we are successful in making the directory. So it will print directory created in the console itself. Otherwise it will print directory not created. The next system call we are using is getCwd. So what getCwd is doing is we can get the current working directory by using this system call. So its return type is character and the parameters are buffer and which is of character type and size underscore t size. So now we can see how it is done in C language programming. Firstly, we are declaring as for the buffer and giving the size 100, so it is a character array for, and then we are printing where we are calling the getCwd and we are passing as a buffer in the argument and its size is 100. Directory will return and by %s we can get the name of that working directory. Now we are using chdir for change the directory. So the syntax for chdir is it is returning int data type and we are only giving the path name in the argument list. So in chdir we are giving the argument as demo, that is the path name, and by get, now if we again do the getCwd, we will see that the path is changed from the previous one to demo. Now the next system call is open directory, open dir. So in this function it is returning dir and the parameters are path name unistd.h. Now here firstly we are using open dir to open the current directory. If dir is equals to null, then we will print open dir in console and it is an error. and then the loop will run where till dp not is equals to null. So dp is direct pointer dp. So it is a structure type variable we have created. Pointer dp is pointer to a structure pointer. So till it is not is equals to null. So as dp is the pointer variable, we are accessing a structure field dname of the dirent. This is dirent. So if you can see them, just type man dirent. You can see that there is a structure made there, and in that there is a field of name dname. So what this is doing is, by using this statement we can select the file name of the directories, the files present in the directory, and dp is equals to read dir. By this we are reading one by one each directory. So till the dp not is equals to null, since we uh, since we will not reach to the end of the file, the loop will keep running. After at last we are closing the directory by close dir, and for that also we can see the syntax. It is returning int and dir pointer dir. The next system call is rmdir. It is the remove directory. So the syntax is, we are returning, here it is returning int type, and the parameters are only, there is a path name parameter. So we are only giving the path name, and the header file is unistd.h. So in rmdir we are giving the path name as it is written operating system, so it is working in the current directory. In current directory it will find a directory with name operating system and it will remove it. So if it returns 0, it means you are successful, and it will print directory removed, else it will print directory not removed.
So next syscall is get time of day, having having parameters as struct time well pointer tv time zone pointer tz. Here we are using two structures, well and time zone. The return type of this system call is integer. In for time well, get time of day ampersand tv null. So here, as we just want to use time well value, so we are giving time zone value as null. If it is not working, then it will give me error and it will return -1. We can print the number of seconds and number of microseconds from the structure fields such as tv underscore and tv underscore usec.
Next system call is get hostname. So here the return type will be character. I forgot to write it. So it is character. And the arguments are character pointer name, size underscore t length. So in the program what we are doing is, we are making an array of name host name, and we are giving it size as 1024, and at 1023 we are assigning null. With the function getHostName, we are giving this hostname here and the size. So what it will do is it will return the hostname. In %s, we get the name of the hostname, that is the username. In the terminal, you can see that the username from which you are logged in, you get that name in the terminal itself by this. So in next program, we are discussing about system calls, that is open, read and write. So for open, the return type is int and the arguments are pathname of character, inflex, more underscore t mode. For read, it is int fd, void pointer bf, size underscore t count, and returning s size underscore t, and return time for write is also the same, that is s size underscore t. The arguments are int fd, constant character pointer buffer, size underscore t, and count. And the other system call is int close int fd is the argument. So the open system call is what it is doing is it is opening the file. The path name is given here in the character feed argument. We can give the flags, but it is optional. So in our program, we are only giving the mode, path name and its mode. In the read system call, int fd is for file and it is the buffer, and here we'll give the size for the buffer and same as in the write, and the how much it reads will be returned in s size underscore t and same as in s size underscore t for write. So now we can see the program. We are using command line argument. So this is the declaration for the variables. We are giving three arguments. First one is to run the program. Second and third argument is the file names. The first one is the source file from which we are, and the second one we are copying from first file to second file. So in that way we are giving two file names. So the argument count is not equals to 3. We will print give two file names so as the other person knows that it is required to give two file names to perform the further operation. So if it is 3, so in IFD we are opening AR in ARGV1, we will get the first file and we are giving its mode as 0666. So we are opening the file in this mode, the file given in the second argument, that is ARGV1. The first argument is ARGV0. In that we are written the command to execute the program. So if IFT is equals to -1, we are just written open in the terminal and then returning 1. Again, if it is OFT, we are opening it is same as the previous one. Here we are opening the second file with the mode 0666, and if -1, then again error. Here it is also error. -1 means error, so I need to correct it. It is error. Now here the logic is. So while RETN is a variable of data type s size underscore t, and in IFT there is a first file that is in argv1 and percent buffer and 1000 is the size. So the whole this thing is giving the length which is read by this function, and it is returning this to ret underscore n. So we can see that here %d we are doing typecasting as it is of size underscore t, so we are converting it in int data type, and for in the format specifier is %d, so we are printing it here the size whatever this system call will read. Then ret underscore out is equals to write oft ampersand buffer size underscore t ret. So we are here doing is to write whatever we read here to here. In IFT there is a first file, and in OFT there is the second file which we have given in the command line argument. So we are writing everything from this file to this file. At last, here we are checking one more condition, that if these two are equal or not. So as we are writing everything from here to here, so it should be equal. So if it is not equal, then you are doing some kind of mistake. Then at last we are getting this. So as we have opened the two files, so here we are closing both of those files. Other system call, the next one is lseek, and the return type is of underscore t, arguments are intft of underscore t offset and int length. Now the program is, firstly we are opening the file in the read mode. For this we are using header file this. After that we are assigning a buffer in character. It is a character type variable of name buffer which you will use here. So till we are giving the size, it is a read function. In previous example I already tell you what it is doing, so you can understand it. Here we are writing the buffer. So what was the previous one is, and now what lseek is doing. So it is the file, this file. We have opened this sample ex.c, and it is in this file variable which we read here till 19 length. And here we are performing system call in this file. We are giving the length as 10. It will read till 10th character. So again read that file by this read system call, and then this %n buffer is used to print that file that now what is in that buffer. So by this output you can see, like, here we are reading till 19 character and we are printing it here by lseek. We are offset it with 10 character and we can now read it only 10. The other system call is app truncate and truncate. These both are similar only with a minor changes. So in app truncate is returning int data type with argument as int fd. It is for file and it is to denote the length of the file. The header file we are using for this is unistd.h. So as the argument is int fd, we have to open the file first. So that's why we are using open system call, and here we are giving the name of the file which we want to open and the mode. So what app truncate will do in this file read12.c, it will truncate the file after the 100 character, means from 0 to 100 it will be there in the file, but after that it will be deleted. You can check the output by opening the file after executing this program. Now that the system call is truncate, it is same as the app truncate. The only difference is we are giving path name directly here instead of giving the file name. So we need not to open the file like this and then doing app truncate. We can only write the file name or the path name here. Again, it is path name. So this file is in a current directory, that's why I'm directly writing the path name. And the size. So after 15, it will read from 0 to 15. After that, it will truncate the file, same as that truncate. Other system, the next system call is rename. It is returning int, and we are giving old path and new path in the argument list. Header file is unistd.h. Int I is equals to rename read.c, read12.c. So it is the old path, it is the new path. So initially the file name is read.c, and by this system call and giving this parameter, it will change read.c to read12.c. After that we can print it %b comma I. If it is 0, then it is successful. Next one is link. Return type is integer. Parameter are constant, character, pointer, old path, new path, same as the previous one. Here we are doing the linking. Like here, sample ex.c, we are linking this with this. If it is successful, it will return 0, otherwise if it is not successful, it will return -1. So we can check it here. And also in terminal you can write ls to save, and then you can see previously it is not existing and then it will exist. Unlink is just reverse of the link. So here we need to give only path name and return type is int. Unlink text.txt will unlick text.txt. Again, if it is -1, it means text.txt not found. Because if it is not already linked, then how can you unlink it? So it will give -1 in I, and then this message will be printed in terminal. Chmod is to change the mode for file. So in this system call, chmod is returning int data type. It is returning integer value, constant character pointer path name, mode in the screen mode. These are the arguments. Okay, so as it is returning integer data type, we are using c is equals to get the value that it returns. The file name is sample.txt, that is in the current directory. So you can firstly check it, what is its mode. So if you do chmod and write here 0777 or 0123 or 0220 or whatever you want, you can see that the current mode is changed to this mode. If c is equals to -1, then you are unsuccessful in doing this, so it will give error. As chmod is similar to the previous one, chmod only, the only difference is here you have to open the file. So for this open system call is used, and the rest of the things are same.
The next system call is stat and chown. Stat has parameter as constant character pointer path name and struct stat pointer buffer. It returns integer value. Here the stat is the default structure provided by the C. In chon, it returns integer value. It has three parameters: constant character pointer path name, uid underscore t owner, gid underscore t group. Here first we need to provide the file name in character array. First open the file in write mode, and then close the file pointer. Now call the system call stat with character array fn and ampersand info. Ampersand info is the variable for stat structure. This uh, this structure stores the information about the file uh, user and group ID. Here, as we can see, the original owner was 0 and group was 0. Info.st underscore UID will print the user ID of the file name given by us, and st underscore gid will print the group ID for the file. Now, on changing the owner ID to 25 by the system command chown, we will get the output as owner is 25 and group is 0. The next system call is CHROOT, change root. The parameter is constant character pointer path name and it returns the integer value. Here First we need to apply change directory system call to /demo. It will change the current working directory to demo directory. Now for changing the root directory, we need to apply chroot and the path name for the directory we want to jump. On successful completion, it will return 0, otherwise it will return any number other than 0. Now we are opening the file simple.txt in read mode. We have simple.txt file in our demo directory. So now as we have changed the root directory to demo, so we can read the simple.txt file from it. So this is the code for reading the simple.txt file. First we are opening the simple.txt file in read mode and reading by fgetS. FgetS has a first parameter as buffer, which is used to store the value of the file. Then size of buffer is the second parameter, and f is the file pointer. And then we are simply printing the file content. Next system call is access. Access has return type as integer and parameters as constant character pointer path name and integer mode. The path name is the name of the file or the whole path to the file, and mode are f underscore ok, r underscore ok, w underscore ok, and x underscore ok. First, f underscore ok is used to see whether the file exists or not. So, access system call will look into the system whether the link1.c file exists or not. If it exists, it will give output as file exists, and if it don't, it will give the output as file does not exist. Second, the access system call on r underscore ok mode will check whether the file given in the first parameter is readable or not. When it will give output equal to 0, the file is readable. On giving the error number as ENOENT, the file does not exist. If the error number is EXF, then file is not accessible by the current user. Otherwise, file is not readable and is access denied. Third, when the second parameter is w underscore ok, it checks whether the file is writable or not. When it gives the output as 0, the file is writable. Otherwise, it may give error as EXS, which means file is not writable, or EROFS, which means file is not writable. It is only in read-only file system, else it will return the error. Fourth, which is x underscore ok, which means that file is executable or not. It will give the output as 0, which means it is executable. Non-zero integer means it is not executable. The next system call is pipe. Pipe has return type value as integer and it accepts the file descriptors with the array of 2. Another system call is fork. Fork has return type as PID underscore T and has no parameters. Here the integer value of result is string the output of pipe from pipe system call. After applying the fork system call, the PID is equal to 0, then it is the child process. And if PID is other number than 0, then it is the parent process. Here in child process, we have here in child process, the enter a message is printed on the console, which is uh, which is given by the user, and this message is written in FD1. And in the parent process, the message is displayed on the console, which was earlier accepted by the child process. Okay, so next system call is get PID. The return type is PID underscore T, and there are no parameters. Here we are assigning an integer x as the value 3. The ID of type PID underscore T is storing the value for the child process called child process created by fork. If id is equal to 0, then child PID is getting printed by get PID. Otherwise, if otherwise in parent process, it is printing parent PID by the system call get PID. The next system call is get PPID. This is get parent process ID. The The return type of this system call is PID underscore T, and it has no parameters. My PID is storing the process ID by the system call get PID. Parent underscore PID is storing the parent process ID by the system call get PID. So here we are printing parent PID by the system called get PID, and parent PID by the system called get PPID. Okay, so next system call is execlp. It returns the integer value and has three parameters. First is constant character pointer file. The second is constant character pointer argument, and third is A. A should always be null. First, we are creating a child process by the fork system call, and then if the PID is equal to 0, we are executing the system call execlp. bin/ls is the file pointer which gives the output of the ls command. So here all the so here this system call execlp works as same as the ls command.
LX, LS.
So here the system call execlp works same as the ls command. After printing all the documents and files in the current directory, it will print the child complete message. Thank you.